In this video, we'll introduce a simple smart contract that we'll install on the chain. This is a very simple contract that only maintains a counter variable. To follow along, you can clone this repository. A smart contract is a self-contained program installed on chain. In the context of a Casper network, a smart contract consists of contract code installed using a deploy. Before writing contracts for the network, developers should be familiar with the difference between contract code and session code. Session code always executes in the context of the account that signed the deploy containing the session code. On the other hand, a smart contract, which is stored on-chain logic, executes within its own context. Session code has only one entry point, call, which can be used to interact with the session code. A smart contract can have multiple entry points that will help you interact with the contract code. Any action taken by the session code is initiated by the call entry point within the session code. Any action undertaken by a contract must initiate through an outside call, usually via session code. When a put key call is made with the body of the session code, the key is added to the account's named keys. When a put key call is made within the smart contract context, the contract's record is modified to have that named key. For more information on how to write session code or contract code, please consult the documentation. So when should we use a smart contract? Smart contracts exist as stored on-chain logic, allowing different users to call the included entry points. These contracts can, in turn, call one another to perform interconnected operations and create more complex programs. On the Casper platform, developers may write smart contracts in any language that compiles to WASM. In this tutorial, we will focus specifically on writing a smart contract in Rust. The Rust compiler will compile the contract into WASM binary. After that, we will send the binary to a node on a Casper network using a put deploy. Nodes within the network then gossip deploys, include them within a block, and then finalize them. After finalizing, deploys within the block are executed by the network. Now let's look at the structure of the contract in the main.rs file. NoMain is an attribute that tells the program not to use the standard main function as the entry point. NoStd is the attribute that tells the program not to import the standard libraries. Here are some of the required dependencies for this contract. Casper Contract is a library for developing Casper smart contracts. This crate contains the API required to author smart contracts. Casper types are the types shared by many Casper crates for use on a Casper network. We also have constants that we will use within the contract, including both entry points and values. The contract also has entry points which serve as a means to access the code installed in global state, which is the storage layer of the blockchain. These entry points may be called by either session code or another smart contract. Each entry point is effectively equivalent to a static main entry point in a traditional program. When defining entry points, begin with a no-mangle line to ensure that the system does not change critical syntax within the method names. The call function starts the code execution and is the function responsible for installing the contract. At the time of contract installation, pass in parameters as runtime arguments. This way, you will collect any values that dictate your contract's behavior. The call function replaces a traditional main function and executes automatically when a caller interacts with the contract code. Within the call function, we define the entry points that the caller can access. Use the new contract method to create the contract with its named keys and entry points. This method creates the contract object and saves the access uref and the contract package hash in the context of the caller. The execution engine automatically creates a contract package and assigns it a contract package hash. Then it adds the contract to the package with the contract hash. Usually, these contracts are upgradable with the ability to add new versions. To add a new contract version, you will need the Access UREF to the contract package. Without the Access UREF, you cannot upgrade your contract. If you want to prevent any upgrades to a contract, use the new locked contract method instead. The next video will show you how to test this contract locally before installing it on a Casper network.